Hello students! Welcome to my channel. You all know me. My name is Svadhyay, and in this channel we do physics, chemistry, maths, biology for class 11th and class 12 for IIT physics, JEE and all. So until now we have discussed many topics in physics and chemistry. In this class we will discuss some topics which no educator will provide you, like the stopping distance of vehicle and reaction time. So this is a topic which everyone ignores, but these are main topics like stopping distance of vehicle. What does it mean? What does it mean? What does the stopping distance of vehicle means? Just simple. Stopping. It is a tendency of a vehicle stop. Okay. It is stopping means it is a tendency of vehicle rejecting the motion, and distance at certain distance a vehicle is tending to stop. It is called stopping distance of vehicle. Okay. How can you derive a stopping distance of vehicle derivation? So in the CET or neet, they won't ask, in the IIT, they won't ask you derivation, or they won't ask you what is stopping power of vehicle. They just give a formula, like a vehicle is traveling with the initial speed of 10 meter per second. Then at what distance it will be stopped. This kind of problems they will ask. So how can you derive a formula for this? It's just simple. Let us assume you are traveling in a car. So you travel certain distance. And suddenly someone appears here. You will try to stop as much as you possible. You suddenly put brake just to stop this. Okay. Yeah. Now you have applied your brakes, and this vehicle, you applied your brakes here. Okay. You applied your brakes here, but the vehicle is stopped by moving certain distance until this. The vehicle stopped. Why this? This is known as stopping distance. Okay. How can you derive this? Just simple. For a moving car, you have started at certain point. Okay. This car you have started at certain points. Means it is clear that you have initial velocity. Okay, yeah. You have started by intentionally a car to drive somewhere. So it is clear that it has initial velocity. But you are not intentionally stopping this. Okay. Which means you won't have a final velocity. Okay. Which means no final velocity. Okay students, we got it. It has initial velocity. Stopping distance has initial velocity because you have started at a distance, at a point, but you have no final velocity because you are not stopping at your wanted point. So how can you derive this? You know the formula of acceleration, like final velocity is equal to initial velocity plus 2ax. This is one of the formula of acceleration. We have derived 3 formulas of acceleration. Okay, this is one of the formula of acceleration. Now the distance, the stopping distance, x, this is the stopping distance. This is the stopping distance. Okay. Now let us take stopping distance x as d of x, stopping distance. Okay. Just substitute this value in this and this value in this. What is saying? It's saying no final velocity, which means v is equal to 0, no final velocity. And v naught, you have initial velocity, plus acceleration, you have acceleration, and x, you have d of x. Just substitute these values. What you will get? 0 is equal to v naught plus 2a into d of x. Okay, yeah. Just shift this v naught to this side. What you will get? 2a d of x is equal to minus v naught. Shift this to this side. D of x is equal to minus v naught by 2 of v. So this is your stopping distance. By just having your initial velocity and the acceleration of your car, you can just notice what is the distance you have traveled, stopping. So it's very easy. You have initial velocity. If you have velocity, you can easily calculate acceleration now. Which means if you have velocity, which means distance divided by time. Okay, velocity you got. Okay, they are given you velocity. Now acceleration you can easily calculate. How? Acceleration is equal to velocity by time. Very easily you can solve this kind of problem. And here always remember the stopping distance is directly proportional to the negative sign of initial velocity and 2 times of acceleration. Okay, what? The stopping power is directly proportional to, like, d of x stopping power is directly proportional to negative of initial velocity, or you can write just velocity, initial velocity, because negative or positive we are not applying here. So you can write it is proportional to the initial velocity and it is inversely proportional to the acceleration. Okay, students. So this kind of very easily you can solve this formula. Now let us discuss another topic, which is reacting time. Before that, if I had a student, I would show you demo with very convenient way. Reacting time or reaction time. It's like just simple. When someone's suddenly come and said you I love you. Someone suddenly came and said you I love you. So first you will be like stunned. Is she saying for me? You will think and you understand, yes, she is saying for me. Oh, she is saying for me. That kind of reacting time. So in the physics, how can you relate a reacting time? Just for example, see, this is a paper. This is my another hand. Okay. So now I will try to lead this paper by this hand, like this, and try to catch from this hand. How? Look. Okay. Another. Okay. So this paper is traveling up to this distance, right? Traveling up to this distance until which I can react from this hand. Why? I am thinking first when I leave this paper, I am thinking in mind either to catch the paper from this hand or to leave it as. So I am taking a time to think and react. This kind of phenomenon is called thinking and reacting or reacting time. If you can try this with your friends, take a whole paper and just tell them to catch if they can. If they can catch them and you will give anything. They can't catch because when you leave this paper, you have a sense I am leaving this paper now. But your friend won't have a sense that you are leaving this paper now. So he can't able to catch the paper. You will try once with your brother, like I can catch it, but your friend can't catch it. Why? देखिए स्टूडेंट्स, ये पेपर मेरे हाथ से मैं छोड़ रहा हूं, तब तो मुझे पता होगा मैं कब छोड़ूंगा एंड कब पकड़ना है, मुझे पता होगा. लेकिन अगर आपके आगे जो इंसान है, अगर आपके आगे वाला एक इंसान है, आप उसके सामने पेपर छोड़ रहे हो तो उससे आप पता नहीं चलेगा कि आप कब छोड़ेंगे. तो आप इस पोजीशन पर छोड़ेंगे भी ना, तो वो क्या करेगा, सोचेगा कि पकड़ूं या ना पकड़ूं. उसके बाद थोड़े टाइम के बाद पकड़ेगा. जैसे एग्जांपल, मेरे सामने एक इंसान है. अब देखिए मेरे सामने जो इंसान है उसके साथ हम खेलेंगे. अब एक बार ओके. आई कैन कैच इजीली. आई कैन कैच बट ही कांट कैच. I can easily catch. See, another time. I can catch because I know when I will leave the paper and how to catch a paper. But the man in front of me, he don't know. He don't know when I will leave the paper. So let's try with this fellow. Catch it. Nah. This kind of time taken by observation to react is called reacting time. For suppose you are you are driving a bike. Suddenly something came, animal or something. You will think first and you will react. That kind of reaction is called reacting time. Now let us derive a formula for this reacting time. Because in every problem, you just need a formula with which you can substitute 2 or 3 quantities and you will get an answer easily. So in this reacting time, always remember, in the reacting time, what you have, what you won't have. In the reacting time, just observe one thing. When you leave the paper, it is constantly attracted by gravitation. Or when you leave an object, it is constantly attracted by gravitation. And in this case, you won't have initial velocity because paper is not traveling. Paper paper is not traveling from one side to another side. It is just attracted by another force. It is not traveling, baby. It is just attracting by another force. So you won't have initial velocity. So what you can write, initial velocity is equal to 0. Now we have a formula which is by acceleration, which is x is equal to ut plus half at square, half booty square. Beautiful. So now initial velocity is 0. This is x is distance. We can write x distance as d of x. Okay. So now just substitute these values in this, and yeah, you know acceleration. What is meant by acceleration? Acceleration means gravitation is directly proportional to negative of acceleration. If it is moving from top to bottom, it is proportional to positive. If it is moving from down to up, it is this. What this is? Down to up. This is up to down. Okay, students, very easy. Now just substitute these values in this. We can find the t. What we are taking time to react, we can find that. So easy, yeah. Just substitute these values. X is equal to what? X is equal to d of x, and u is equal to, this one is 0, mean totally 0, plus half, a means minus g, and t square. T means d of x square. Now just simply substitute these all values. What you will get? D of x is equal to minus half g t x square. Just we want t dash, so we can send this to this side, 2d of x divided by g, 2 divided by g minus is equal to tg of t. Just square it on both sides. You will get what you will get. You will get like by g. This become positive. Okay. You get a final answer. This kind of final answer you got. What? Just simple. No, this you won't have. T of x is equal to square root of 2 into d of x divided by g. Very easy, students. Very easily you got the answers. You got answers in seconds. So you are getting in seconds. Very easy. So now we can calculate. If we have distance, we can easily calculate the time. How? For suppose, just imagine this is a wood. Something wood. This is a wood. This is a wood. I am leaving this wood. Okay. Like I am leaving this wood. Okay. 1, 2, 3. No. 1, 2, 3. So now my friend in front of me, he catches. I left in this position. Now he catches at this position. So what is the distance when I leave this? When my friend catches this, oh fuck shit. When I leave this and when my friend catches this side, this is traveled distance is 21 centimeter or meter, 21 meters. So now we have to calculate the time taken by that person to react and catch it. So how can we calculate that? We know the distance traveled by this is 25 meters. D of x is equal to 25 centimeters. Just substitute this value in this. What you will get? Value T of x is equal to 2 into 21 centimeter, and gravitational what? 9.8 meter second square. So meter second. So in this is in centimeter, but in this is in meters. Just convert this centimeters to meters. How can you write? Converting that centimeter to meter, you can write 2 into 0.21 meters. Now down 9.8 into meter per second. This meter will cancel. So you will get final answer like 0.2 seconds. The time taken by a person in front of me to react and catch the wood is 0.2 seconds. He is taking 0.2 seconds of time to react and to catch that. So this kind of very easily you can solve. Remember this formula. This is very important. This is very important. They won't ask you derivation. They will ask you this kind. And you have d of x is equal to minus v naught square divided by 2. So these are the two formulas which we have derived now, and these are very important for the IIT exams. So this kind of formulas definitely ask. So let us end this section here. I hope you liked this video and you have watched it until this point of video. A very thank you, and please like and share if you can with your friends if you want them also to improve. And thank you once again for seeing this video, and salute.